This is Sukruti Joshi. Our today's topic for this video session is Introduction to Nuclear Chemistry. Now we all know that chemistry is basically can be divided into many types, and depending upon the application of chemical principles, we can actually divide chemistry into many parts. So when we do the study of nucleus, that is atomic structures, one of the most important part, right? We all know that atomic structure can be divided mainly into two parts. Number one, atomic nucleus, and number two, atomic orbitals. So here actually we will study about atomic nucleus, which kind of reactions will be there and what is the actual meaning of nuclear chemistry, right? So we'll take a look in this particular session here. So we all know that in a chemical reaction, atoms of the reactants combine by a rearrangement of extra nuclear electrons, but the nuclei of the atoms remain unchanged. In a nuclear reaction or in any kind of nuclear reaction, on the other hand, it is the nucleus of the atom which is involved. Now, the nucleus contains protons and neutrons. So, the number of protons or neutrons in the nucleus changes to form a new element. Actually, the core of any atom is its nucleus only. If any kind of change occurs in particular nucleus, then that particular atom's identity will be changed. Okay? It will create a new element or it will create another element. So here the number of protons and number of neutrons in the nucleus changes to form a new element, as I said. So a study of the nuclear changes in atoms is termed as nuclear chemistry. Now let's take a look that what will happen actually when sudden change or when any kind of change will be done in number of protons or number of neutrons. That means when any kind of change will be done in the nucleus, the atomic nucleus. So what will happen at that time? Actually, the atomic nucleus contains a very high number of or very higher energy. So when any kind of change occurs in the nucleus, so there is a change in energy. Now that particular energy releases itself or that will be released in the environment in different forms, right? That particular release of radiation, that is known as radioactivity. That is an emission of radioactive rays or radioactive whatever we can say, radioactive rays. Okay, so here what it means is basically the types of radioactive decay. That means when any substance change its identity or change in proton or neutron or change in nucleus occurs. So at that particular time, it will release certain radioactive radiations, right? And that is the particular phenomenon is radioactivity. So we will see it here depending upon a theory. So according to the theory put forward by Rutherford, that is Rutherford and Soddy in 1903, radioactivity is basically a nuclear property. So it is the property which is shown by atomic nucleus. Now, the nucleus of a radioactive atom is unstable, right? It undergoes decay or disintegration by spontaneous emission of alpha and beta particles, right? So basically it will give you either an emission of alpha particle, either an emission of beta particle. So this results in the change of proton neutron composition of the nucleus to form a more stable nucleus, right? So what actually happens? The proton and neutron balance that is imbalanced, and when such kind of imbalance occurs, it will emit the radioactive radiation. It will emit the radioactive rays, right? And in that term, they will become a stable nucleus. So it will try to create a stable nucleus, right? The original nucleus is called the parent nucleus, which becomes unstable, and the product is called as daughter nucleus. So the first nucleus, or the first one which becomes unstable and emit radioactivity or shows radioactivity, is known as parent nucleus. That parent nucleus loses some of the electrons or some of the protons, some of the neutrons, and or either it can gain also and convert itself into parent nucleus, into daughter nucleus. That means a product nucleus. That is basically the product, right? The first one is a substrate, and they will shows radioactivity and they will give you daughter nucleus. Okay, as evident from above, there are two chief types of decay. Number one, alpha decay. Number two, beta decay. So alpha decay, let's talk about that. When a radioactive nucleus decays by the emission of an alpha particle, which is also known as alpha emission, from the nucleus. The process is termed alpha decay. Here, an alpha particle has 4 units of atomic mass and 2 units of positive charge. So if Z be the atomic number and M be the atomic mass of the parent nucleus, the daughter nucleus will have atomic mass which is M minus 4 and atomic number will be Z minus 2. Okay, so that means that here the alpha emission reduces the atomic mass of the parent nucleus by 4 and the atomic number of the parent nucleus by 2, right? So for an example, radium decays by alpha emission to form a new element radon, which is 88 radon 226 minus 2 alpha 4, right? Here radon is a parent nucleus. So alpha decay occurs and it will convert itself into, here as you can see, the 86 Rn 222 forms, which is known as daughter nucleus, right? So in general, our daughter nucleus will contain two less in its atomic number and another way, right? Now our second one is beta decay. So in beta decay, what will happen? When a radioactive nucleus decays by beta particle emission, which is also known as beta emission, it is called beta decay. Here a free one particle or electron does not exist as such in the nucleus, and it is produced by the conversion of a neutron to a proton at the moment of emission. Now this results in the increase of one positive charge on the nucleus. So the loss of beta particle from the nucleus does not alter its atomic mass. For a parent nucleus with atomic mass M and the atomic number Z, the daughter nucleus will have atomic mass which is same as of the parent nucleus, so remains M. And atomic number is increased, so Z plus 1. So atomic number will increase by 1. Right? So in beta decay, the change in atomic mass will not be seen, but change in atomic number or increase in atomic number will be observed. Right? Thus, a beta emission increases the atomic number by 1 with no change in atomic mass. An example of beta decay is the conversion of lead 214 to bismuth 214. So here Ag2Pb214 is known as parent nucleus. So one beta radiation or one beta decay occurs. One beta decay occurs and it will create here 83 bismuth 214. Now as you can see, the atomic mass remains same, but the atomic number increases by 1. So here it is known as daughter nucleus. Okay. Now we will take a look on nuclear reactions. So in a chemical reaction, there is merely a rearrangement of extranuclear electrons, right? So the atomic nucleus remains intact here, and the nuclear reaction involves the change in the composition of the nucleus. So the number of protons and neutrons in the nucleus is altered, and the product is a new nucleus of another atom with different atomic number and different mass number. Thus, a nuclear reaction is one which proceeds with the change in composition of the nucleus so as to produce an atom of a new element. Right? The conversion of one element to another by nuclear change is called transmutation. It is known as transmutation. Now let's see that what is the difference between nuclear reactions and chemical reactions. So nuclear reactions proceed by redistribution of nuclear particles, while chemical reactions proceed by the rearrangement of extranuclear electrons. In nuclear reactions, one element may be converted into another, while in chemical reactions, no new element can be produced. In nuclear reaction, it is often accompanied by release or absorption of enormous amount of energy, while chemical reactions always accompanied by release or absorption of relatively small amount of energy. The rate of reaction, that is the rate of nuclear reaction, is unaffected by external factors such as concentration, temperature, pressure and catalyst, while the rate of chemical reaction is influenced by external factors. This is all for this session. Next we will see in our next sessions. Thank you so much everyone.